Welcome everyone to my channel Chemistry Made Simple for Neet. I am Dr. Radha Subramaniam with a PhD in Chemistry. So today we are going to make a quick revision of Electrochemistry Part 3. Already I have uploaded Part 1 and Part 2 videos of Electrochemistry. So before moving on with today's session, a few students had asked me some doubts regarding NEET 2022 exams. So I will be discussing a few questions here for you. The first question is, what are the maximum attempts for NEET exam? So for that there are no restrictions on the maximum number on attempts for NEET. Okay, now another question one student asked me was that in how many languages can one attempt the NEET 2022 exam? So in NEET 2022 students will get the option of writing the paper in 13 languages, say English, Hindi, Assamese, Bengali, Gujarati, Malayalam, Kannada, Marathi, Odia, Tamil, Telugu, Urdu and Punjabi. Okay, another question is, which type of questions comes in the NEET 2022 exam? So I will tell you briefly the exam pattern for NEET 2022. That is, the total number of questions is 180 questions to be attempted out of 200 questions, and the exam mode would be pen and paper based mode and MCQ types of questions. And duration, this year they have extended the duration to 200 minutes. Okay, next question is, can students with a year gap between classes 11 and 12 appear for NEET 2022? Yes, students of with a gap of 1 year between class 11 and 12 can now appear for NEET. Earlier such students were not allowed to appear for the exam, but after the judgment by Delhi High Court, the restriction is no more in practice. Okay, now next question is, what is the NEET 2022 application fee? The application fee for different categories will be, for general category it is 1500 rupees, for OBC, NCL and general EWS it is 1400 rupees, SC, ST, PWD and transgender it is 800 rupees, and processing charges and GST is also applicable. Okay, next question is, what is the mode of payment of fees for NEET 2022? So applicants can pay the fee via online mode, net banking, debit, credit cards or UPI. Then another question, can the application form be cancelled for NEET 2022 once filed? Will fees be refunded? Once you submit the application form for NEET, you will not be able to cancel your candidature. Also, there is no provision for a fees refund. Okay, we will discuss 2-3 questions more. How many total questions are there in the NEET exams? There are 200 questions in the NEET exam. You get a choice in section B of the exam, and candidates only need to attempt 180 questions in total. Then, as you all know, the main subjects in NEET would be physics, chemistry and biology. Around 75% of the questions are based on NCERT books. Then, what are the maximum marks in NEET? So candidates need to attempt 180 questions in total. So each correct answer carries 4 marks, and the maximum marks would be 180 into 4, which is 720. Okay, then one last question for today is, are there any safety provisions by the NTA for the NEET exam? NTA increased its examination centers to ensure proper social distancing. Besides this, sanitizers and masks are compulsory. The examination centers are disinfected according to COVID-19 protocols. There is also a chance that the examination may be conducted twice a year. Okay, now we will be moving on to the next topic of electrochemistry. So already we discussed about the magnitude of conductivity, its variation, that depends on the nature of the material, and mainly it depends on the temperature and pressure at which the measurements are made. And already I said in our last session that materials are classified into conductors, insulators, semiconductors depending on the magnitude of their conductivity, and metals and alloys have very good conductivity, and so they are known as conductors. And non-metals like carbon black, graphite and organic polymers, these are also electronically conducting. Just for refreshing what happened in our last class, that is why I am just going through this briefly and quickly. Then you know, substances like glass, ceramics, they have very low conductivity, because of that they are known as insulators. Then like silicon, doped silicon, gallium, they have conductivity between conductors and insulators. So these classes of substances are called semiconductors. They are of high importance in electronic field, and certain materials known as superconductors have zero resistivity or infinite conductivity, means they don't have any resistivity at all. Earlier metals and their alloys at low temperatures were known to behave as superconductors, but now lots of ceramic materials and mixed oxides are also known to show superconductivity as at very high temperatures like 150 Kelvin. Then electric conductance through materials, it's called metallic or electronic conductance because of the movement of electrons. So, we can classify that on the basis of the nature and structure of matter, the number of valence electrons per atom and temperature. Okay, it decreases with increase of temperature. Now, what happens is that in the reaction at cathode, manganese reduced from +4 oxidation state to +3 oxidation state, and ammonia is produced in the reaction when hydrogen and nitrogen reacts together, and also here it forms a complex with zinc, okay, and you get a product, coordinate product like this, and for here the cell will have normally a potential of 1.5 volt, and mercury cell, which is suitable for low current devices like hearing aids, watches, etc. Mainly it consists of zinc and mercury amalgam as anode and a paste of mercuric oxide and carbon as cathode. And electrolyte would be a paste of KOH and ZNO. Remember all these, like what is used as anode, what do we use as cathode, and what is the electrolyte. Then the electrode reactions for the cell, always you should remember which reaction occur at the anode and what happens at the cathode. See, at the anode, zinc or Hg plus 2OH gives zinc oxide plus water plus 2 electrons, and at the cathode HgO combines with water and 2 electron to form Hg, mercury, and 2 OH minus. Then you can write the overall reaction like this: zinc plus HgO gives ZnO plus Hg. See, it's a displacement reaction, and here the zinc cell potential would be 1.35 volt. They will be giving you this particular reaction and asking you about the cell potential. Remember, it's 1.35 volt, and always throughout the overall reaction it remains constant, and it does not involve any ion in solution whose concentration is changed during its lifetime. Okay, hope you are clear with this part. Now, so for the equation, it gives a relationship between the equilibrium constant of the reaction and standard potential of the cell in which the reaction takes place. The equilibrium constants of the reaction, it is difficult to measure otherwise, and in the last class I had explained on how to calculate it from the corresponding value, E value of the cell. Okay. Then also you can calculate equilibrium constant from Nernst's equation. So, normally in the circuit in Daniell cells, it is closed when you note that the reaction, see this particular reaction which we are discussing, zinc plus copper giving zinc Zn2 plus and plus copper, here Zn plus Cu2 plus. Zinc will lose electrons and attains Zn2 plus state, and copper will accept those electrons and becomes copper metal. And what happens when time passes? Zn2 plus keeps on increasing at concentration, while concentration of Cu2 plus will keep on decreasing. So, at the same time, voltage of the cell is read on the voltmeter. I showed you in the last diagram representing that you can see the voltmeter used for the reading and the switch setup, and the voltmeter reading keeps on decreasing, and after some time you can see that there is no change in the concentration of Cu2 plus and Zn2 plus ions, and at the same time voltmeter will give you 0 reading. It shows that the equilibrium has been attained. So, how will you find out that equilibrium is attained? By looking at the voltmeter, which gives you 0 reading. So, here the next equation can be written as, you can see here, at 0 equilibrium, E cell minus 2.303 RT by 2F log Zn2 plus Cu2 plus. Okay, so from here you can calculate E cell equal to in this step you are rearranging and writing 2.303 RT by 2F log. Remember, this formula is very important with respect to solving sums for equilibrium problems. Okay, now we will just go through a summary of the uses of Courant's law. Firstly, calculation of molar conductivity at infinite dilution for weak electrolytes. That is the first use. Secondly, you can calculate the degree of dissociation, which is otherwise very difficult to find out. Then thirdly, you can calculate dissociation constant for a weak electrolyte. Finally, calculation of solubility of sparingly soluble salt. What is meant by sparingly soluble? It's only little bit soluble, not completely soluble. So these are the main 4 uses which is given as a summary for your reference. Okay, now what are primary batteries? So different types of batteries are there. So primary batteries, what happens is that the reaction occurs only once, and if you use it for over a period of time, battery will be dead and you cannot reuse it again. See, for example, you use such type of batteries in a radio, remote control, so many gadgets nowadays. You use this type of battery. Then the most familiar example, as I said, is dry cell. It's also known as Leclanché cell. It is discovered after the discoverer's name only. This name is given for the cell, and it is commonly used in our transistors, clocks, and all that. Here the cell consists of zinc container, which acts as anode, and also a cathode, which is a carbon or normally graphite rod surrounded by powdered manganese dioxide and carbonate, which acts as an electrolyte. And the space between the electron is filled by a moist paste of ammonium chloride and zinc chloride. The electron reactions are complex, but you can write it like this: at anode, Zn gives Zn2 plus 2 electrons, and the cathode MnO2 plus ammonia plus electron gives MnOOH plus NH3. Now clear this primary battery part. Okay, now what happens for weak electrolytes like acetic acid? The equation Ka becomes, or K alpha becomes C alpha square by 1 minus alpha. You can substitute for alpha square here like this, and Am square, and you get an equation like this finally. And what are the applications of Coriolis law? Using this, you can finally it's possible to calculate E0M for any electrolyte from the delta 0, lambda 0 value of individual ions. For weak electrolyte like acetic acid, it's possible to determine the value of dissociation constant if you know EM0 and delta M at a given concentration C. Okay, now voltaic cell, already we went through that part. Voltaic cell, you can just look here for reference, and earlier session also I have conducted this part on cations move towards the cathode and anions move towards the anode. Here zinc is the anode and copper is the cathode. As you can see the voltmeter over here with the switch, right hand arrow, blue arrow shows the movement of cations, and this one shows the movement of anions. Now we will go through Faraday's law of electrolysis. Faraday's 2 laws of electrolysis. First one is the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. Now the second law says that amount of different substances given out by same quantity of electricity passing through electrolytic solution are proportional to their equivalent weights. So atomic mass of metal divided by number of electrons required to reduce the cation. So according to Faraday, Q is equal to IT. This is a very simple equation which is used to solve certain sums based on Faraday's law. And what are the products of electrolysis? Mainly the products depend on the nature of the material being electrolyzed, and I have already discussed this part once. Again we are just going through this concept quickly. Suppose the electrode is inert like platinum or gold. What is meant by inert? They do not participate in any chemical reaction and they act only as a source of electrons. So if electrode is reactive, it participates in the electrode reaction. The products of electrolysis may be different for reactive and inert electrodes. And secondly, the product of electrolysis mainly depend on different oxidizing and reducing species present in electrolytic cell and a standard electron potential. Now some of the electrochemical process, though possible, they are also very slow kinetically. At lower voltage they do not seem to take place at all, and extra potential, which is we call it as over potential, has to be applied. Only then this reaction can process, or it is very difficult to process it unless you apply an external over potential. Okay, now what are batteries? Batteries, actually it may have one or more than one cell connected in series. It is a cell we use as a source of electrical energy. That is basically a galvanic cell where the chemical energy of the redox reaction is finally converted into electrical energy. 2 types of batteries are there: primary batteries and secondary batteries. Already I discussed about primary batteries. And the fuel cells are galvanic cells which are designed to convert the energy of combustion of fuels like hydrogen, methane, methanol, etc. directly into electrical energy. These are called fuel cells. Basically they are galvanic cell and they can convert energy of combustion of fuels directly into electrical energy. And the most successful fuel cells uses the reaction of hydrogen with oxygen to form water. That is a common example. And in the cell, hydrogen and oxygen are bubbled through the porous carbon electrons into concentrated aqueous sodium hydroxide solution. And here we use finely divided catalysts like platinum. Why we use catalyst? To speed up the reaction. And palladium also is another catalyst which can be used and for increasing the rate of the reaction. Now, the electrode reaction, always it is very important in electrochemistry. Whenever you say about a reaction taking place in the cell or fuel cells or whatever it is, you have to write the or know about the equations occurring at the anode and the cathode. Here cathode oxygen plus water plus 4 electrons gives 4 OH, and at the anode 2H2 plus 4 OH gives 4 H2O plus 4 electrons, and overall reaction can be written as 2 H2 plus O2 gives 2 H2O, that is the making of water. And the cell almost runs continuously so long as you supply the reactants, and fuel cells produce electricity with efficiency of about 70%. When you compare with thermal plants efficiency is just about 40%. Okay, hope it is clear for you. Now, what are alkaline batteries? You can see alkaline batteries, we have got a gasket here, and this is a separator, and this part is cathode, mostly it is MnO2, manganese dioxide plus graphite, and anode it is zinc plus KOH. And lead storage battery is an example for secondary battery. You can see the diagram here. There is an opening for adding water here. Then this is sulfuric acid and water which is taken in here. Then we have got positive plates which are lead grills fitted with lead dioxide. We have got a separator, see here. Then the negative plates come here. These are lead grills filled with spongy lead. So that is all about the secondary battery. You have to be very familiar with this diagram. And secondary cell, after use the most important part of it is that you can recharge it again by passing current through it in the opposite direction so that it can be used again. So good secondary cell can undergo a large number of discharging and charging cycles. The most important secondary cell is the lead storage battery. We commonly use in automobiles and inverters, and mostly it contains lead anode and a grid of lead packed with lead dioxide as cathode, and 38% solution of sulfuric acid is used as electrolyte. And the cell reactions when the battery is in use are given here. You can just see anode lead plus sulfur SO4 gives PbSO4 plus 2 electron, and at cathode PbO plus SO4 ions plus 4H ions plus 2 E gives PbSO4 solid and water liquid. Overall cell reaction occurring together at anode and cathode can be written as PbO2 plus 2H2SO4 gives 2 PbSO4 plus H2O. When you charge the battery, the reaction is reversed and lead sulfide on anode and cathode is converted into Pb and PbO2 respectively. Now, how can you prevent corrosion? See, whenever water droplet is coming into contact, here zinc is the anode and the reaction occurring here is Zn gives Zn2 plus 2 electron. Iron is acting as cathode, oxygen plus 4H plus 4E gives 2 H2O. So normally to prevent corrosion, we paint the surface, and for electrolytic methods are all there. Electroplating, these are all a few methods to prevent corrosion when the metals or elements come in contact with oxygen of the air in presence of moisture. And hydrogen fuel cells, you can see here, and the setup for that is here we have got the anode, and in between the porous membrane with the cathode, and oxygen inlet and hydrogen inlet, and here the exhaust of water and oxygen, and hydrogen exhaust over here. So what happens here is that the mainly when you discuss about the secondary cell, it is the nickel cadmium cell which has longer life than the lead storage cell but more expensive to manufacture. So the overall reaction due to discharges, cadmium plus nickel hydroxide will give you cadmium oxide plus nickel hydroxide plus water. You can see the setup here for nickel cadmium cell. We have got a cap here and a vent valve. This is the cover, and you have got a seal here and a positive tap with a core here, and it is enclosed in a can with the separators, and we have got the press powder negative electrode and positive electrode here. Insulating washer comes over here with a jelly roll. Okay, now With that, we are coming to an end of today's session, and we are finishing off with the topic electrochemistry. I will be uploading the most important MCQs of this chapter very soon after we complete all the other units, and all of you just watch the other previous units before coming to this unit. And always, as I say, please do like, share and subscribe to my channel, and do not forget to press the bell icon so that you will get the notifications as soon as I post new videos. And hope that you enjoyed watching this video, and until I come up with a new video at the earliest, thanks for watching.